All right, Chance, share with me your game plan.
Different on the game plan. 1 year, 2 years. How much it loses each year?
How much it loses each year. Okay. And so from year 1 to year 3, you're going to find that it loses like 2.2-ish. So what's that tell you? From year 3 to 4, you're going to find out that it loses 0.8-ish. I'll give you a hint, or maybe someone else can give you a hint. What's the key phrase here? Tyler? Linear regression. This is a calculator question. We are going to, and we just did this, we're going to enter our data. So on your calculator, Alyssa, what do we hit to enter data? Stat, then edit, excellent. So I'm going to clear out what's there, and I'm going to enter, whoops, oh boy. Clear out what's there, and I'm going to enter 1, 3, 4, 6, and 9. If you don't have a calculator, go get one. For list 2, 8.579, 6.328, 5.641, 3.791. Thank you, Austin. There is no frequency list here because no data point is happening multiple times. So when we go to run our regression, we don't necessarily need to see the scatter plot, but we're going to run our regression, and Cole, remind me what I need to push to run a regression. The stat button, and then what from there? Over to calculate, and then down to 4, linear regression. They were nice enough to tell us it was linear. They don't have to do that. So linear regression, enter. My x coordinates were in list 1, so that's all set. My y coordinates were in list 2, so that's all set. There is no frequency going on here. And then I'm going down to calculate. So I get negative 0.8 as my a coordinate, which is my slope, and 9.1 we'll say as our b, which is our y-intercept. So on this, number 21, as far as if I were showing work, I would say enter the data, run a linear regression, and I just got y equals negative 0.8x plus 9.1. And so, determine the x-intercept. The x-intercept is when, what equals what? Yeah, that's a flashcard, by the way. I have that on a flashcard. For the x-intercept, it's when y equals 0. So I would make 0 equals negative 0.8x plus 9.1. And then I would solve that.
Ms. Williams?
Yes?
I would say I could get all that stuff, you know, the test and all those terms printed.
Yep.
Could you probably print that for me?
Yeah, Mrs. Marquis could probably help you too.
Probably give it to Ms. Marquis when you're done.
Yeah, well, we can do that. That's a good skill. You should be able to go online. We can help you go online and print that out. So negative 9.1 divided by negative 0.8 tells me that my x-intercept is 11.375. Okay? So if I look at my options, what can we eliminate? 3 and 4, I would say. 11.375 is definitely going to round to 11 out of the whole numbers. So now what does 11 represent? Does it represent the initial amount of money owed in the college loan, or does it represent the number of years it will take to pay off the college loan? It's your x-intercept, so you're waiting until your y value is down to 0. If you're waiting until your y value is down to 0, and we just found out that our x value would be 11.375, what does that 11 stand for? Yeah, your number of years since graduation. So after 11 years, you will have paid off your loan. So it stands for the number of years it will take to pay off the loan. Number 2. Any questions on that? Okay. Number 22. Take a minute. Read that. Get started on it if you... he could just make a copy of mine. Yeah, thank you though. So what kind of question is this? What do you think, Sarah? Yeah, writing the equation of a parabola, okay, given a focus and a directrix. Now, they were pretty nice to even tell you. They kind of gave you enough information in the word problem for you to diagram this, but we have a focus, so I'll put 22 on my loose leaf sheet. We have a focus at 8/16, so we always started these problems by sketching. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Doesn't need to be exact, but there's your focus. And the directrix is at y equals -8. Okay? So, first things first, where's the vertex? The vertex is always halfway between the focus and the directrix. So what would be the coordinates of that? 8, 0? But 8, 0 is only 8 units away from here and 16 units away from that. So what's halfway between? It's definitely on this line at 8 somewhere, but what's halfway between -8 and 16? What's halfway between -8 and 16? First of all, these are how many units apart, from +16 down to -8? Good, 24. Okay, and what's half of 24? 12. So I need to go 12 below this and 12 above this, which should land me at the same point. What's 12 below 16? 4. So our vertex is at 8, 4. Which we don't really need that point, but we do want to kind of eyeball where it is. And does our parabola open up or open down based on the diagram? Up. It always bends away from the directrix. Okay? So, the game plan for a problem like this is always two distance formulas. So, we put a generic point on the parabola. So I'll call that point P for just point. And we have two distance formulas. The point to the focus has to be equal to the point to the directrix. Yes? Two distance formulas. So we'll start with point to focus. It's a big square root symbol. You obviously have to know your distance formula. It's y minus 16 squared plus x minus 8 squared. Yes, Jake?
Can you answer the other one second?
For number 22?
Yeah.
Not yet. I want you to follow through this and then I'll show them.
All they do was,
So that's our point to focus. Now, point to directrix. We need to come up with a point on the directrix. What would the coordinates of that point be, Alexis? No, I'm looking for the coordinates of this point. X comma negative 8. Perfect. We don't know the x number. It's just the same as whatever this x is, but the y coordinate is negative 8. So when we go to do our distance formula over here, we have y minus negative 8, which will be y plus 8, and x minus x, which is just going to cancel. So to solve this, we immediately square both sides, which just takes off the radical. So we'll just lose our radical on both sides. And then you should only have 3 parentheses squared remaining. Which 2 of the 3 do we actually square out? The y's in this case. It depends on what there's 2 of, and there's 2 y's. So I'm not going to touch this. I'll leave that alone. But this I'm going to square out to y squared minus 32y plus, what's 16 times 16? 256. Plus my x minus 8 squared equals, and when I square this guy out, it's y squared plus 16y plus 64. And what variable do I try to get all by itself? Y. You should always have 2 of those y squareds on both sides, so those just cancel. And since I've got more on my left, I'm going to leave that all there. I'm just going to get all my y's over to the right-hand side. So the 16y is already there. I'm going to add my 32y over. So I got all my y's on the right, but I also have to lose this 64. So I'm going to subtract this 64 over as well. So 256 minus 64 is 192. Plus x minus 8 squared equals 16y's plus 32y's is 48y's. And then I divide both sides by 48. So 192 divided by 48 is 4. This just has a coefficient of 1 over 48, x minus 8 squared equals y. And that's my answer. Do you remember what we said the vertex was? Look at your diagram. What did we say the vertex was? 8, 4. Do you see that? 8, 4? Okay. That's on this parabola's vertex form is one of your flashcards. The front says parabola vertex form. The back says this, where HK is your vertex. So we have 8, 4 there, and so we are pretty confident that our answer is right. And then just look at your answers. Which one matches? Look up here. Option 4. So, case in point here, I don't have a flashcard on reminding you all how to write the equation of a parabola given the focus and directrix. But I'm going to create one right now, so I'll add it to the list. If I have a focus and a directrix, okay, and I'm asked to write the equation of parabola. Okay, you have to pick a point P on there. So this will be the front of the card, and on the back of the card, I'm gonna put the distance from P to F equals the distance from P to D. And then I'll do this big, like, square root thing and trust that you know the rest.
So you're gonna print those down?
I will. I think Mrs. Marks is right out there, so we'll...